All right. Now, this is a straightforward problem. Now, in this case, we just try to find grad phi, div and curl f once f and phi are given. Recall that the gradient operator is this one. Now, if we switch to the first problem, grad phi, so you write the grad operator first and then the function phi. So, what happens is when you operate, when this operator is applied on this function falls onto these places, right. So, here we are left with this one I partial over partial x. Now, you have this function phi. I could have even substitute phi there, and finally, I could have substituted this function. Now, then this one falls on top of this one. So, you will end up with this line. After that, you have to get the partial derivative of this function. So, the partial derivative of x squared is 2x. The other terms are considered to be constants. In the second case, partial derivative of y, then these three terms are considered as constants. So, you end up with 2yj, and here again the partial derivative is 2z, therefore, you have 2zk. So, this is how you compute, you find grad phi. It is quite straightforward. Now, let us find div f, divergence f. Divergence f is the dot product between these two, where grad operator comes first, right. So, this is the grad operator dot the vector field given in the problem. Now, in this case, you know, first you have to get the dot product. So, I dot I is 1, however, I dot j is 0, I dot k is 0, we know that. Here I dot I give you some non-trivial value, so it is 1. Therefore, this function falls on top of this one. So, you will end up with partial over partial x with x squared plus 3 here. Again, in this case, again j dot j is 1. Therefore, this function falls on top of this one. So, you have partial over partial y. Here the function is y plus z. Similarly, in this case, this function falls here with k dot k is equal to 1. Now, you simply get the partial derivatives. Here you have 2x, here the partial derivative of this is 1, the partial derivative of this with respect to z is 2. It gives you 2x plus 3 as the answer. Here it is not a vector because it is a dot product, and div f is a scalar all the time. Now, if you move to the third one, curl f is simply the cross product between the grad operator and the vector field f with grad operator comes first. Now, in this case, this is the grad operator curl, and this is the function, this is the vector field. Now, if you want to get the dot product, the easiest way is to get it as the determinant. You first write the components the unit vectors I j k in the same order, then the components of the first vector. So, you have partial over partial x, partial over partial y, partial over partial z in the second line. Then in the last line, you have to include the components of the third vector. So, x squared plus 3 comes first, then y plus z, then 2z minus x. Now, evaluate this determinant. So, I times this cofactor. So, I times partial term should be written first. So, partial over partial y with 2z minus x minus this product. However, partial should come, the operator should come first. So, partial over partial z of this one, you have this. Similarly, minus j times, you have to take minus of this second vector. Then you delete this row and this column. So, you will end up with these 4 terms. So, you evaluate that determinant. So, partial over partial x with this one, you have it here, minus partial over partial z with this one, you have it here. Finally, in the last term, plus k times, right, you leave this row and this column containing k, then you take this product partial over partial x with this one minus this term. Now, you simplify it. So, I times the partial derivative of this is 0 because it is free of y, partial of partial z of this one is 1. However, you have a minus sign here in front, therefore, it is minus 1, then minus j times, here the partial derivative of this is minus 1, it is straightforward, I mean no explanation is needed. Here it is 0, so we have here. Then the partial derivative of this is free of x, therefore, it is 0, this is free of y, therefore, it is 0 as well. Therefore, you have plus k times 0 minus 0. So, if you simplify this, you will end up with minus I plus j. Okay, all right. Thank you.